That's terrific. Thank you very much, Dumaris. That's a lovely introduction, and I appreciate it very much. And welcome to all viewers from Ireland. We're experiencing some very wet weather now, just very briefly. We've been January, 28 days of the 31 days, raining every day. So hopefully it'll ease off. Anyway, to get to the presentation at hand, beginning with the picture that's before you, this is Miss Purity. And rather than sort of ramble a little bit, which sometimes I might tend to do, I'm going to read from the text. I thought it'd be more productive to do it this way, and then we can get questions and answers at the end, which I'll be quite happy to answer. So back in early 1970, I attended the annual SAE Congress and Exposition held in Cobo Hall, Detroit. It was during this event that a technical paper and presentation about electric vehicle technology was given by Dr. Richard Thornton of MIT, in which he mentioned a hybrid vehicle car competition that had been held in 1968 between MIT and CalTech alone, just the two. And as a result of this event, a much larger competition open to students of all universities and also open to all forms of automotive propulsion was planned for that August. This is 1970, only 6.5 months after this presentation he was making. I, at that moment, having completed my mechanical engineering degree at U of T, was pursuing a master's degree and was deep in the intention of building a steam-powered car, not too different from Bill Lear's then effort to enter the Indianapolis 500 with such a vehicle. I even visited him. Dr. Thornton, whom I met at the conclusion of his presentation, and he, being such a gracious and lovely person, invited me to have lunch with him and 2 of his industry sponsors. During the course of the lunch, I took the opportunity to enter the U of T into this race, as if I had any right to do so. But in any way, proceeding on from there, and the U of T of entry, in my mind, would obviously be my steam-powered idea, or so I thought. But as an amusing side effect of this lunch, one of Dr. Thorne's sponsors made the suggestion that the proposed route for the race not go through Cleveland as originally planned, but be rerouted through Toronto so that his product advertising could claim that this was an international race rather than simply a national event. So I walked straight into it, not only a race entry, but the entire race to end up at the door of the University of Toronto. You want to go to the next slide here. Okay, can you click onto the next slide, Dumaresque, if you're hearing this? Perfect. So this led straight into what turned out to be the most amazing and positive response by the U of T and its engineering faculty, particularly the mechanical engineering department. The idea was enthusiastically welcomed and championed by Professor Phil Hughes, and then the idea quickly spread to Professor Frank Hooper and IW, which we use referred to as I Omega Smith. And in the end, the full support of the university itself, which was to include the hosting of all participants of the newly named Clean Air Car Race during the one-night race stop over in Toronto. It was at this point that a U of T CACR Clean Air Car Race Committee was formed in order to discuss how best to proceed. The final and agreed path forward for the vehicle itself, owing to the serious time constraint, was to proceed with an internal combustion electric hybrid vehicle. It was also urgent to arrange for funding, which was secured through 2 engineering bequests, the William Wallace Foundation and the Coburn Unit. Also, we enjoyed support and included from General Motors Corporation in Detroit, who was very generous and gave us $2,000 US, and the use of a Chevelle station wagon for the duration of the race. And along with that, GM Canada as well chimed in, and they gave us the use of a brand new Vandura van as well for the duration of the race. We also had support from Gulf Oil, Fiberglass Canada, Dunlop for tires, Superior Propane up in Maple, which I'm sure everybody knows, or many do. Exide, ESB Canada, they produce the batteries. Uniroyal Limited, Dominion Auto Accessories, Purolator Limited, not the delivery company, but this Purolator, probably a division somewhere along the line there, who made custom filters, air filters, and so on. And as well, we had support from the Ontario government and the Ontario Department of Energy and Resources, who was very kindly gave us their portable chassis dynamometer, in which we were able to do emissions testing prior to the race itself. Now, clipping, can you clip back to one photograph back, Dumaresque? If I think there's a pic, that's the one I'm after. So we skipped this. But anyway, so this photograph here of the U of T committee members, most of the members from left to right are Professor Frank Hooper. Next to him, Ken Bell, we'll come back to in a minute, Yuri Otsuson, myself, Steve Baker, Professor Phil Hughes, and Professor Smith, Omega Smith, and the girl smiling with her hand over her mouth, she was the secretary of the mechanical engineering department, and who's just visible to the right is Professor Sid Segsworth of the electrical engineering department. Now, I'm going back to Ken Bell because he was not the U of T at that time, but he was actually my cousin who was attending the Ontario College of Art, and he was responsible for styling, and he led the building of the Miss Purity fiberglass body, along with Steve Baker and some other students as well. So now we jump on to the next picture. There we go. So as I said in my own write-up here, I'll read it anyway. So we jump over the actual building of the car straight into the race. And in this photo, two unique features appear. The UT1 Ontario license plate, which was a special one-off plate approved by the Ontario government, owing to the special significance of this vehicle and the Clean Air Car Race event itself, which brought positive recognition to Canada, Ontario, and of course, Toronto and its University of Toronto. The second unique feature being Ken Bell's Canadian flag taillights, so no mistaking where this car came from. This picture was taken en route to the start of the Clean Air Car Race in MIT, which was located in Cambridge, Boston. Now, if we go to the next photograph, Dumaresque, yes, that's very good. In this picture, one can see 5 of the 10 12-volt batteries buried as low as possible into the frame of the car. This location being part of the overall design of the chassis and drivetrain of the vehicle in order to accommodate our hybrid concept. The car's prime mover, a modified Chevrolet 302 cubic inch V8 engine with a custom propane fuel induction system and a high energy ignition Vertex magneto. From that to the back, we had an in-out transmission, which transmitted the internal combustion engine output power through a drive shaft, which also incorporated a toothed 2-inch drive belt, a belt drive pulley located immediately ahead of the modified 4-speed manual Corvair rear transaxle. So you have the V8 engine going through an in-out transmission, so you're either in gear or you're in neutral completely, on through the drive shaft, and just ahead of the rear end, you have this transaxle, a Corvair transaxle, and entering in through the front end of it, we were able to modify it and put a tooth belt drive pulley, which was to connect up with one of the electric motors, which I'll come to in a minute. So if one wished to drive all electric, then the rear, there was two 12 kilowatt DC motors. I'll come to the front in a minute, but the rear one was located immediately above the transaxle and was connected by this toothed 2-inch belt pulley, which was concentric around the drive shaft, and the power went on through into the Corvair transaxle. And so at these times, if we were driving in that way, the IC engine was shut off and the in-out box was placed in neutral or the out position. This motor generator also proved very useful for regenerative braking. Now the second, which I mentioned earlier there, the second 12 kilowatt motor generator was connected to the front of the IC engine, and it was for the recharging of the 120 volt battery pack. So you got 5 12 volt batteries on the one side buried in the frame, and a matching 5 12 12-volt batteries on the other side. So you have a total of 10 12-volt batteries or 120-volt battery pack system. So the second 12 kilowatt DC motor could recharge those batteries or go directly to power the rear electric motor, which now this gave us a pretty variable abilities, so we could drive the car completely as internal combustion, cutting out all the electrics, or we could drive it all electric off the rear electric motor, DC motor, driving through the transaxle at the back. 12 kilowatts doesn't give you an awful lot. It gives you about 16 horsepower, but we were able to double and even triple the voltage going through it for short periods of time for acceleration, which we did. And then you could also drive the car with the front IC engine driving the generator, which was continually feeding the electrical energy back to the rear motor and through the battery system as well. You could float off the two together. Or if you wished, you could use the rear motor to drive the car, and also the two together, the two motors together, motor generator. So on acceleration, you used, in addition to the IC engine, you used the rear motor, electric motor as well, and for braking, both the IC engine would be regeneratively braked by the generator at the front, and the braking system itself would be assisted through the regenerative braking process through the rear motor as well. A little bit complicated there, but it's very, very similar to today's Priuses. So you can drive in 4 different modes, which was very, very useful for us. Continuing on, so the control of the electric motor generators was managed by an electronic logic controlled high-power chopper, which provided the variable motor speeds or regenerative braking as needed. Simon Ng, it's NG, he was our electrical engineering student, and a very bright young guy. Anyway, he was the team member who undertook this complicated facet of the drive system. Now, as we go from that, we'll go into the next section here, which is a short section of a movie called The Great Clean Air Car Race, which was produced for the Environmental Protection Agency in the United States, who followed this entire race, all the students, all the race teams, and we got a very, very good showing in this particular movie. It's a 25-minute movie. It's up on YouTube if you wish to watch the whole movie, but we got a good spot in it, and they were very, very excited about our concept. So for this next couple of minutes, you'll see one section where I describe a little bit about how our vehicle came to this point in the movie anyway. So if you want to start that up again, that sounds good, Damaris. Thank you.
The most exotic class of vehicles in the race, the hybrids. University of Toronto's team captain, Doug Venn.
When I was visiting the SAE conference in Detroit last January, Dr. Thornton from MIT presented a technical paper in which he mentioned a clean air car race to be held this summer. So I entered the University of Toronto, came back, told them, and they were quite taken by the idea. But after discussing it at some length, we realized that the time element was very critical. So we immediately started to do some thinking about what could be done quickly and effectively, and we came up with this propane electric hybrid idea, which has turned out to be quite successful so far. For our propane source of power, we have a Z28 302 cubic inch Camaro engine, which we have converted to the use of propane fuel, and we're using this in conjunction with 2 12 kilowatt electric motors. Now, we can operate in 4 different modes. Eventually, this could have pretty good commercial application because, number one, it's so flexible. We can run the 4 different modes of operation. If we run out of propane fuel, for instance, then we still have the electric reserve. This makes it ideal for us for a research vehicle because it does give us such a variation of testing facilities. We're not in this race as such to beat anybody. We're in this race to make a point of being involved in pollution control and making the general public aware of the problems of pollution. And I think these are the two principally most important goals. And as far as I'm concerned, everybody that enters this race is a winner.
Thank you very much. That summarizes probably much more succinctly what I was trying to explain through my description. But I think you get the picture. Just briefly, that movie that was shown there, as I said, it was a 25-minute movie produced by, well, actually at the time was the National Air Pollution Control Administration, which got absorbed into the EPA later in that year. And it was actually narrated by Orson Welles. They made a very good effort at producing that movie. And in many other sections of that movie, they cover many of the other vehicles, or a number of the other vehicles that were included in that race. But that gives you a little bit of a starting point of how we got into this, or how we and others got into this this whole area of pollution control and vehicle drive systems. And my steam car idea kind of went by the boards at that point, which I think you can appreciate. But it did lead from there into what you're looking on the screen right now. And this was a concept for that came right up on the heels of it. So I don't know whether to, I'm kind of going off script here, probably just as well that I do. Let me just finish off a little bit about the history of Miss Purity, just to wrap that up and close that off. The movie, the Miss Purity Clean Air Car Race movie, it was produced for the EPA, Environmental Protection Agency, and it was at the invitation of the EPA that we, the University of Toronto, Miss Purity was featured in Washington, D.C. at the International Clean Air Congress and Exposition in November 1970. And we were treated, they rolled out the red carpet for us. They really, really did us proud. It was fantastic. And God bless them all. Anyway, so Miss Purity then went on to the NRC in Ottawa for further development and testing for 2 years. And Don Buchan, also a graduate from University of Mechanical Engineering, went with the car to assist and lead in their test program. And then Miss Purity went dormant then for over 40 years until it was recovered with the goal of restoration. And to date, Miss Purity has been partially restored. However, and sadly, the person and my good friend leading this effort, it was a man named Mr. Ron Passer. He's up near Schaumburg, Tottenham. Anyway, he recently passed away last Boxing Day. So I made a note here to say that if you are aware of anyone interested to pick up and carry the baton of this restoration project, please let me know or contact Doomresk and let us know if this is possible. Anyway, the success of the Miss Purity project then became the bridge into our VR1 vision and the formation thus of a company called Vehicle Research Limited. So in this photograph this picture that you're looking at now, we made a discussion as to the possibility of proceeding with a new concept and the car. What you're looking at there, these artist renderings, which were done for us by it was one of my neighbors, Bill Davies, who at that time was the highest paid commercial artist in Canada and had a lovely studio down in Yorkville. But he drew this up, and it was very much captured the essence of what we were aiming for in terms of a small 2-passenger vehicle, which would demonstrate our system. So this is what we were aiming for in visionary or artistic aspect. And so the Vehicle Research Limited came into being and included 5 individuals, all from the University of Toronto. Now, I'll go through the participants. There is Professor Stu Robertson, Professor Gord Sleman, Professor Sashi Dewan, and Professor Sid Segsworth, all being U of T electrical engineering faculty and professors. And there was myself, the only mechanical engineering member of the team. Anyway, and the idea was to develop, test, and demonstrate the feasibility of producing a new concept of an urban electric passenger vehicle, but using three-phase AC drive and exchangeable battery packs to improve usability. Now, this would be the first time that a car was, a passenger car, at least anyway, was produced and using alternating current motors. It was an induction motor, three-phase induction motor, and it worked very well. If we go on to the next photograph or the next picture, please, Dumrask, I'd appreciate that. That's excellent. Okay, so the VR1 on this particular photograph is on display in the University of Toronto, and it was conceived with the thought of designing an urban electrically propelled passenger car, applying the latest three-phase AC induction motors and SCR, silicone control rectifier power supply. And secondly, a vehicle utilizing the latest and lightweight body construction. Now, the ultimate design idea was a vehicle made like a clamshell and fiberglass, two sort of balsa, how'd you call it, balsa or similar reinforced fiberglass section tubs, two halves, the suspension being a simple lightweight steel, and between the two halves, you can see the perimeter, the rubber band around the outside was very helpful for bumper purposes, but also it concealed the join points of this bottom shell and the top shell, which and all the innards were sort of contained within that. So that was the idea. Now. But so to begin with, as it was, the initial vehicle was thought best to begin with a lightweight steel space frame within the fiberglass sections, and which it was, and that worked out well. Now, if we look at the next picture, please, Dumrask, I'd appreciate it. Okay, so this is the VR1, the side view, black and white. The profile rubber section bumper surrounds the vehicle, covering the split line of the lower and upper body sections. You can see, obviously this was in the winter time, it was snow behind us there. Anyway, and that shows you the overall concept of the shape of the body. And then we can move on to the next photograph here, please. Now the front wheel drive, the three-phase induction AC power supply. It was 25 kilowatt three-phase induction motor, proved adequate at in-town speeds, and through variable gate triggering of the SCR power supply, it was possible to double or even momentarily triple the power for short durations while accelerating. Of course, the engine starts to overheat if you can't continue this for beyond a few moments and so on. And of course, the regenerative braking was a big bonus with this as well. In spite of the popular belief that electronic devices are next to 100% efficient, they are, or at least were, not, in fact, the situation which we were, that we found out in doing this. It came to the conclusion when this system was up and going that the system was about 85% efficient. And there was heat loss from the SCRs and the switching systems and so on still. And it necessitated the use of water cooling with a small radiator to prevent overheating of the high power devices. So there was a little bit of a snag in there, but it was dealt with as we went along. But it worked fine. But it's an additional kind of a consideration that was added to other aspects as we grew into this development, so to speak. The next photograph shows a rear view of the car, and because of the limited range, it required exchangeable battery packs. Lead acid batteries have many advantages. Unfortunately, high energy capacity is not one of such advantage, at least for electric passenger cars. So we were able to get about each lead acid battery, just as a matter of interest, can have a kilowatt hour storage of between about 0.6 and about 1.2 kilowatt hours. Ours were about 1 kilowatt hour per battery. So we had 12 batteries, 12 kilowatt hours. And so you can get something like about 3.5 to 4 miles per kilowatt hour in most cars, including all the cars you see on the road today, all the electric cars, which means for 12 kilowatts, you got a range, if you're getting say 4 miles per kilowatt hour, with 12 kilowatts, you've got, it's very easy, 48 miles range, which was approximately what it turned out to be. With that limited range, and that's at best on level roads and at ambient temperatures of between, say, 15 to 22, and this is it, okay? Thus, to make it possible to keep the vehicle on the road without long periods of recharging, then it was necessary to devise a quick method to do a battery pack swap. Now, so you can see behind there's a little split line on either side and above the two backup lights and the license plate, and that whole panel underneath, that valence, clipped off with Zeus connectors. And it led to the next picture, which you will see here, the battery pack. Now, this is seen here in this photo is a partial battery pack. It's not the full 12 batteries. A normal pack having 12 volts, 144 volts, which would roll in and automatically connect electrically to the whole system, and similarly would likewise disconnect and roll out on rails straight onto a wheeled dolly for a recharge, and then you could roll in another charged battery pack. And it worked very well. There was one little snag we had to overcome, and as the battery pack on the first try on this to roll this out on the dolly, as the battery pack's rolling out, of course, the weight of the batteries is coming out of the car and onto the battery, and so the suspension of the car is lifting the whole back of the car up and away from the dolly. So all of a sudden, yeah, the rail connection is getting a little bit tense there. So you have to either clamp it, which we did, and make a more permanent connection or a more fixed connection of the dolly onto the rails, which is very straightforward. So we got it to work. But the first go around, we had the battery pack kind of suspended, tilted on a car that was going up, and the dolly, which was resting on the ground. But we sorted that out. It was one of these little kind of things that you run into. Anyway, so this was the concept of doing the battery pack swap. Worked fine, and that gave us, it made the car more usable, although every 50 miles or thereabouts, you're into doing these swaps, which doesn't give you a huge range. But anyway, we're after the concept here to see how this whole thing can be put together. Now, if we move on to the next picture, this is the interior view. One of the additional and serious considerations is how to provide heat for winter driving and the more optional air conditioning in summer. So in order to have satisfactory performance in winter driving, it is essential to have cabin heat for the passengers as well as heat for the defrosting of the windows. To do so by drawing energy from the batteries kills the range of the vehicle so much that other alternatives to the provision of heat had to be considered. We ended up looking at this company. It's a German company, Eberspatzer, who make kerosene heaters for motorhomes, etc. But it started to get us all a little bit frustrated, because now we're right back to square one of now having to accommodate fossil fuels back into a car which is supposed to be all electric, just to overcome a deficiency with respect to the range issue that is still working very much against electric cars to this day. But the battery storage, energy storage these days has improved vastly, so it's not quite the same. Still, it's a problem. Anyway, so that was a quick shot of the interior of the car there. And if we go on to next photograph, so here it's just simply a 3/4 front view of the car, and it's very cute. We demonstrated it across Canada, right from Alberta. We went to, remember, to university campuses, and then right into the motor show at Bonaventure, Place Bonaventure, du Bonaventure in Montreal. And we had some nice coverage from various the media newspapers all along the way in Montreal, in Alberta, as well as we had several articles that appeared in Toronto publications as well. But it was demonstrated across Canada, and it was the government at this point, when we met with various ministers and Department of Industry, actually with the Ministry of Industry and Tourism in Ontario, and took the minister around for a ride, and he was very pleased and so on. But I think we were starting to get, we can start to see the difficulties that in terms of something of a car that was road ready in one sense, was not in fact road ready because of the number of limitations that we were encountering. But it certainly was a good starting point to get to the to pursue the idea of alternating current, battery swapping, and other issues that could be very usable. Some of which have been applied to, especially the electrical power supply. So what's the next picture there? So, oh yeah, and I just want to see how we're doing. I'm not doing too bad on time, it's a little bit rushed. So the next picture here, myself, and you had a little hatch at the back, so you had put in groceries and store a certain amount of stuff, and the taillights, because of all the electrics and things down below, we moved our taillight necessity up over top of the rear window there. You can see them across the top. So you had your brake lights and your tail lights and so on located in that position. And so if we go to the next picture, and so here's a close-up of the power supply and the motor and the drive going into the transmission. There was a front-wheel drive, obviously, because we had the back consumed with the battery storage. And we had 21 high-powered SCRs. And it was interesting during the construction. There was one interesting event that happened in the process of constructing the battery pack. You had 12 volts, and there was one of the workers was working on doing this, making all the connections from battery to battery. It's all series connected. And the very last, I was working in the car doing some assembly, and right behind me, he was assembling the battery pack. All of a sudden, there was like a shotgun, the sound of like a shotgun going off, and a strike of lightning that was just frightened everybody in the place. And to find out that he had accidentally dropped his spanner, his wrench across the two ends of this system, 144 volts with a flash of lightning that and a sound like thunder that just shocked everybody. And his face was over top of the battery pack, and all the shower of sparks that came off that went on either side. Nothing touched him. It was a miracle. And when he looked at his former wrench, it was originally started off at maybe about 10 inches. It had now just 5 of those 10 inches had completely vaporized and disappeared from his wrench. So when you're playing around with these electric these levels of electricity with unregulated power coming out of it, you have to be very, very careful. They can be very dangerous. So it's nothing to fool around with in that respect. But anyway, you can see this where the engine is, of course, and then behind the SCRs, and they are all connected onto an thin aluminum box behind the surface that's facing us. And there is enough space in this box to accommodate the flow of water to take the heat away, and then off to a radiator located in the side wheel well. So that was where the water cooling was located. Next picture, please. So we're bringing around now back to the demonstration that in this particular day, in this instance here, you can see Miss Purity in the background. It was at the University of Toronto, and you can see a little red car that was another American attempt at a low emissions vehicle, and of course our VR1 in the foreground there, and myself. So that's sort of brings us around the story of the VR1 in general in a very brief explanation. And we'll end on this one more picture here. We have, yes, back to the questions and answers, and with the painting done by Bill Davies. And I think that probably gives you, as I say, a brief roundup of what these two projects were all about, and the support and that we had from quite a lot of people. It was just absolutely magnificent. We were very successful in the race. We got great recognition. We got from the Ontario government, from the American government, from everybody. It was just absolutely so gratifying that. And we even got invited when we were at the race start before the Clean Air Car Race start. We were chosen to deliver banquet invitations. There was a massive banquet at MIT, and the governor of Massachusetts, his name is Francis Sargent, was the guest speaker, and we were chosen to deliver the banquet invitations to him at his office in the legislature, and that got a lot of good coverage from the press as well. So we had very, very good exposure, and it was very, very enjoyable, and the people that we're dealing with all along the way were just absolutely terrific. And on to the VR1, again, excellent support, and we proved our concept. And the one little side story I'll finish off with is that the VR1 concept had one fantastic ongoing successful story. In the middle of this project, we hired a young Irish guy to help out with the construction, and we became friends, and he invited me for a holiday to Ireland, which I came to a couple of years later, and I met his sister, and so we are married and living in Ireland today. So the VR1 project somehow produced me a wife. I don't know, which absolutely, she's fantastic. She's a wonderful, wonderful woman. I just love her dearly. So we have 4 children that we love dearly as well. So that's my story. And I suppose if there's questions or comments, please let me know. Or
yeah. Well, thanks so much, Doug. That was great. I guess as people are typing in more questions, I see some coming in. My first question would be, why yellow for the VR1?
Kind of corny, sort of, you look at all the electrical warning signs and so on for electrical things. It's yellow and black, yellow and black, yellow and black. Being electric, it just sort of, it looked electric. It had that connection, I suppose. Watch out, yeah.
I can't help but be reminded of the Marathon, also a Canadian electric car built about 10 years later, which was similarly plexiglass bodied and also only available in yellow. John's asking a great question. What happened to the VR1?
The VR1 was sold to the Scarborough, I got to remember now, Scarborough Utilities. I got to remember they handled the electricity. We're going back a few years here now. This is back in 1971. So we're going back 55 years now at this point. And they wanted to do some testing with it, and they wanted to promote it. And I can remember it was sold to them, and they immediately took it. It completely disappeared from sight, but they took it, and I know that they painted if you remember the Scarborough Utilities Commission, I'm not sure the exact terminology, their colors for at that time were a pale green and a dark green, and all their letterheads and stuff like that. So what did they do? from the rubber bumper band down. It was dark green, and from there on up it was light green. So they repainted it their colors, and I don't know what they did with it. So it's completely disappeared. So I can't tell you. The only one I can tell you about is the Miss Purity. I know that, which I mentioned earlier on, but I don't know what happened to VR1.
Clark's asking how many of the VR1s were built, because I know in that photo of the battery rack we saw that there was a second one at least partially finished.
Yeah, that was partially finished, and it was the body was all built, and the chassis, it was all built ready to go. And at that point in this, I guess this is sort of the key point where the decision had to be made where this whole thing went to, because that would have been the number two. And then we sat down at that point and made a discussion as to what's the feasibility of proceeding along, one of the paths to in production. And we could see that there was an awful lot of obstacles that made this difficult for us. First of all, we weren't Elon Musk's pockets with money. Our marketing expertise was very limited. We're engineers, we're guys, doing stuff that we think is cool and interesting, which it was. So our marketing aspect was on the weak side. But then and we're way too far ahead of the curve when it came to competing with, was it 50 cents a gallon petrol, I call it over here, gasoline, and so on. And and then with the other complications, what they call it, range anxiety, which is what's called for electric cars today. People have this problem of range anxiety. Are they going to run out before they get to a charge point? And then the fact that you have to also have kerosene in the car to heat the car, and no air conditioning. That was bad. There was just an awful lot of hurdles that were just beyond us to challenge at that point in our lives, I guess in this project. But we had achieved what we had to be reasonable in our thoughts, that we wanted to prove the concept. That was the number one thing, and that was like the Miss Purity rationale and so on. We knew we weren't going to invent and we had 6 months. We weren't going to invent the world, so we had to try and make the point then that the principally important thing, as I mentioned in the thing, was to bring to the attention to the public the need to start dealing with the pollution problem that was at hand. And so that was more to get the involvement of the universities into social issues that were important, and to get the general public aware that these things were real and not just sort of fanciful. So it was to kind of bridge a bit of a gap there, and that worked extremely well. But the one, as I say, the one big blessing on this one was that I met my wife out of it, which was the best deal of all. So that worked very well. So we then went on back to our various, either doing educational works at the university for those who were professors, and I got a job then, as I mentioned there before, with GSW. So that worked out very well.
On the technical side of things, with electric car development, the idea you always run across is reducing weight, getting the absolute maximum efficiency out of the vehicle. Rich and Phil are wondering, do you know off the top of your head how much a finished VR1 weighed?
It was relatively light. I think it was something around 2,100 pounds or something like that. I mean, that was light. The battery, no. 21, that's a different car. It was quite light. It was, say, around 2,500 pounds is a rough guess. The batteries were the big thing, and then the motor and the front drive were the second thing. The body was pretty light. It was a clam shell, and the steel frame was pretty light as well. So it was quite a light car. Amazingly so. I don't know how it would pass, crash tests in these days, because we were just coming into that whole era of safety, increased safety, and so on. And there, I think it was 2 years after that, then they had the 5-mile-an-hour bumpers, crash bumpers and stuff, and more had to be added. And at the same time, they had to try and take weight out by using more plastics and so on. So there's a lot of activity going on in the types of materials that were used, and weights went up and down. But now, so we went on the light side for everything at that point because we could, and we did, and it was possible. But whereas Miss Purity, I know, weighed 4,200 pounds. It was very heavy. It had a steel frame that you could drive a tank through. I mean, it was plus we had a V8 engine, which was and two motors, not one, and a big propane tank that could carry about 60 gallons of propane, liquid propane. So you had an awful lot more weight on that car, even though it was a glass body. It was, which offset a little bit. So the weight, but by today's reckoning, I don't know. I just I'm looking at. I thought I wasn't quite sure what kind of questions were going to come, and I thought somebody might be asking about what the thought is about electric cars in the current situation and so on. From what I can see, where it's at is electric cars are really dandy for around town, anywhere up to about and city driving. You get out into long range drives. The range goes down. You can only charge between 20 and 80%. And then if the weather's cold, or if you get if you have air conditioning, the range goes down again. Or if in the case, I know I was just looking at a Ford F-150 all electric, and if they're towing a trailer, the range is 160 miles. That's it. It's so there's limitations. I think people are trying to put too much, trying to throw the concept everywhere all at once. And some of the applications, I think, are a little bit more than optimistic. They're too fanciful, but it does have a good application for around town. Small car, it's great, it's cheap, and recharge it at home. It's much less expensive. You save a lot of money, but for long range, you're starting to push the envelope a little bit at this point. They will gradually come in. But, a town car, super, brilliant.
Clark's mentioning the sort of two-part body with a rubber joining strip on the car. Yep. Reminds him a lot of Electrolux canister vacuums, and I was reminded that sort of slide-out battery rack design. That's something you see a lot in the 19th century on some of the very first electric taxis. How much inspiration were you taking from other cars while designing the VR1, or was this kind of a project in isolation that it was just whatever works?
I think you have the nail on the head there. It was an isolation. We looked at nothing, nothing older. Now, you can never say that you never look at it, because along the lines, you look at a picture, it could be 10 years earlier, and there's a mental picture that does stay in your memory at some point. And you think, geez, I thought I saw someplace some years ago a picture of this or that or something. And these things do creep into our designs and stuff like that, even though we mentally don't really kind of acknowledge that or recognize that. So possibly some of that did, but that didn't. We just knew that this was a serious shortcoming that we had to address this problem in some form or other, because it was necessary to do so, or at least to prove that it could be done that way. So that was, yeah, you're quite right though.
Phil's asking, where did you source parts like the gear shift in the car, running gear, brakes, steering? Was that commercial? Was that custom designed?
Oh, so yeah, like both cars and so on, same thing. A lot of the how'd you call it, pieces that you need, you can't start making everything. You're going to be, door latches and everything else. You have to start being practical about some of these things. So in the case of I'll go back to Miss Purity car, from the firewall forward it was a brand new 1970 Chevelle that had rolled. It only had like about, I don't know, a couple hundred miles on it. They rolled the car and it was in the scrapyard, and we picked it up because we knew we were not going to start doing power steering things and steering wheels and braking systems and all this kind of stuff, trying to reinvent everything. And we wanted to get a new car, as new car as possible, because the stuff is nice and fresh, and you can undo bolts. You're not dealing with rusted in parts and stuff like that. So we got it was virtually a brand new Chevelle, and we threw away, we stripped out, what we needed out of the interior, bits and pieces, and then discarded the body, and then it had its own frame, which was wonderful. And we just chopped off everything behind the firewall at the back, and off it went. And then we took the whole front drive was basically a Chevelle basket, front end baskets with your suspension, braking, and radiator mounts and stuff like this and so on. The rear, as I say, was a Corvair transaxle. There was an interesting thing that had to be done there, because in the Corvair transaxle, the drive comes in from the back side, not the front. And we had to come in from the front side. And fortunately, there was an access plate there, which we could take off, and you could get access, but there was no gears or anything. So we had to do a kind of a unique connection to get that drive to come out the front, which is normally not. And it was done through shrink fitting. So we had a shaft, a drive shaft made, and it was machined so that the size of the shaft was slightly larger than the hole that was already there. Happened to be approximately, it was about a 3/4 inch hole, I suppose, in the gearing system, which just fortunately happened to be there as an input from the backside though. And so we did an interference fit, and so we took the transaxle apart, got that part that was in the transaxle, and we heated it up, and we took the shaft and we put it in liquid oxygen until it shrunk, and then when they were both at the maximum of the hot and cold, and in a jig that was already pre-made, the two extreme temperature parts were put in there. The whole thing was rammed together, and then it was allowed to then warm up to room temperature, and we had it. It was an interference fit, and it worked perfectly. So we were able to get that front access into that Corvair transaxle, which is normally completely not possible. So that was kind of an interesting. But things like that, certain things you have to adapt in that way. You use parts that you can get, and a number of them have to be adapted to accommodate the overall project. So yes, headlight pots and so on, like for the headlights, well. And in the picture that we're looking at there would be round headlights, but in actual fact, we ended up with the kind of the rectangular headlights, which came from I think it was a Citroen French car, and because everybody had round headlights, and we wanted to see if we could get it a little bit more modernized. Today, it's no trouble; you can make your headlights look like anything you want. But at that time, that kind of was the ones that we chose. And it was Oldsmobile Cutlass tail lights that we used at the back above the rear window. I remember it was yeah. So you're getting bits and pieces here and there from various cars to satisfy those needs at the time. So it's a real hodgepodge.
Absolutely. So, I'll combine we're closing in on time, but I'll combine the last question from Lindsay and David. Given that GM was involved, do you get a sense that they took anything away from the project? They saw the successful propane car and later a fairly innovative electric car design and took any kind of inspiration, or were they kind of, here's the money, hands off?
They were wonderful. Actually, it was interesting. At the race itself, it was there was GM. There were the big three at the time: Ford, General Motors, Ford, and Chrysler. They were number one, and American Motors had an operation up in Brampton, now Chrysler. Anyway, but so it was interesting because GM did when it was announced at that time, the clean air car race did get a lot of publicity. Today, people don't even remember it, so on. But at the time, it was something quite there was enough of it and enough intensity, and it was all across North America that it really got good attention. And so the media, now that they had a whipping boy, they could come after the big car companies and said, "Look at you big guys there. You got these students, you got your multi-million-dollar research centers and all this stuff, and these kids, they come and they do this kind of stuff, and it was kind of like goading them on and so on." And there was two opposite reactions. GM were very supportive. They took the stance, yes, we think that this is wonderful, we should be doing more, and they were doing stuff, but they took the stance, yes, we'll support them, and they gave, I think, 20 entrants in the clean air car race. The most promising ones, they gave them a $2,000 grant and the use of a Chevelle station wagon for the race, which was very good. And they invited all 20 teams that were down for a meeting with the chairman of General Motors at the time at their big research center, and big lunch, and they parked these 20 cars outside the front in a nice kind of a rainbow, and we all came out and looked at it, and all these teams they made a big deal about it, how their largesse, right? And it was good. It was very, very lovely. They were seen to be really in support of, and they were. You can't say they weren't. They were very, very good. And then on the other hand, Ford. The Ford car, we tied first in our hybrid in that section, so we were okay. But the overall winner was a car from Wayne State University, and it was basically a Ford Capri, or I think they called them Mercury Capris at that time, and so on. But it was the Ford took the position to. It was under Lee Iacocca, and they wanted to enter a car in the race, and the race said, no, this is for students. So, and he pressed, and they said, no, it's for students. So he got two of his engineers to enroll in night school at Wayne State University, and all of a sudden, Wayne State University had an entry in the race, which was remarkably supported by the Ford Motor Company. And they proved the point. Yeah, they had the best pollution rating so they came at it at a different way. And other people had their own agendas at the time. My own was Ethyl Corporation. Tetraethyl lead was in all the fuels, right? All the gasoline fuels, anti-knocking, and so Ethyl Corporation, their life was on the line at that point, because they're going to get if the lead was kicked out of that, their business was really in serious problems. So they supported a race from Louisiana State University, and it was a tetraethyl lead. It was an ethyl car entered through Louisiana State, and they had two drivers. They're both co-eds, two very good-looking girls, and who really didn't have much of an idea about cars, but they were very nice looking. And the car, it didn't fare so well, but that's just all history. It's there for anybody to see. So there was so many aspects to the race. It was amazing, but we were treated like kings. I have to say that American government they went beyond everything. They just did everything that we asked for when they brought us to Washington, and they featured us at this huge Congress up on the stage, and the movie was premiered at that event. So we had it was very, very lovely to experience that. So so what the car companies have taken away, I'd say that they pretty much were influenced. They could see it coming, but the whole thing then became an academic financial exercise as to what point do we have to move in that direction. And they were taking steps. They had done some preliminary electric car prototypes themselves, just to see where this thing was going. And so I'd say that, yeah, it pushed it along. We had our part in it, along with probably many other cars as well. But yeah, we had our part both with the VR1 and with Miss Purity and with the clean air car races as a whole as well. So all had a contribution to make to where we are today. I'd say it was part of the picture for sure.